and welcome to our tutorial video on how to code and learn how to code with the Arduino Uno and an Arduino IDE. If you're already familiar with most of this concept, then you might be more interested in one of our more advanced videos, and you're welcome to find them in our channel. Now let's get started. So, what is coding or programming? It's effectively converting the instructions that you want the processor or controller computer to carry out on your behalf into effectively metaphors. So you know what you want to do, but then you have to try to translate that into something that the computer can understand, which is not so simple sometimes. These metaphors then translated into binary codes, to zeros and ones. And that then gets passed on to a processor. A processor can understand that. Obviously, it doesn't understand human language. It doesn't actually understand some of the code you write either. But yeah, so then they execute it, and hopefully the processor does what you expect it to do. Well, most of the time. So let's say you want something like switch on the lights, for example. Pretty straightforward. Human can understand it. Now, how can you get a computer to do it? So a code you would write in our specific example would be just digital write, effectively giving instructions to write a specific pin on your microcontroller board. So in this case, an LED pin with the light on. And you set it to high, which is to switch it on. And you have the brackets in, and because that's expected syntax. And yeah, that then gets translated into binaries. The zeros and ones will not be exactly this binary, but it's just like typing out some binary just to give you a general idea. So that's something where it will look like. And then that binary gets passed on to a microcontroller chip or a processor or a new computer, and then it then understands that and can execute it. So what is an IDE, and why would you need one? I mean, you can develop code without one, right? Yeah, potentially. So let's say you launch a notepad and just use that to write some code and then some more code. So far, so good. You don't get any of the highlighting, though. You don't necessarily see if you make a mistake, but that works. You could write code this way. Some people actually do use basic text editor. But then there's a problem. What about translating this code into binary? And what about then deploying your code? How would you get as far as actually getting it from here and all the way to a microcontroller and then making it run? Yeah, not so simple. So this is where an IDE or an integrated development environment comes in. And that's exactly what you need. So let's have a look at this one, for example. You have the ability to verify your code, upload your code. So it's actually got all the way to the board. You can check some of the code, the serial monitor, serial plotter. You can select the right type of board to kind of have all the board managed in there. Potentially even get the board info directly and automatically. Include some of the code libraries as well. So that's another step. It has obviously basic text editor stuff, like create new file and save one. So it combines it with all the other tools. And serial monitor is specifically important because you can use that for a lot of tracing and debugging. How about installing Arduino IDE? Seems pretty straightforward, just like installing most other programs on your computer. Just search around for installing Arduino IDE. Make sure you look searching for 2.0, because that's the later version. You don't want to get the first version. It's kind of much slower, not quite as nice. So yeah, on the official site, you'll see instructions for every type of operating system. Yeah, you can see for Windows, it's pretty straightforward. You get the installer. Although we would recommend just using the Windows Store on your laptop, if you are on Windows, of course, and just search for Arduino. Make sure you spell that correctly, of course. And what you're going to get is, yeah, Arduino IDE. And by default, you get a version 1. We had that installed from before, and just haven't uninstalled it since. So be careful with that and make sure you install version 2.0. If you have both installed, that's fine. You're still going to get version 2 working, which is, yeah, in many ways, a much better version, faster and easier to work with. So yeah, installing that is pretty straightforward. Well, we got our IDE ready and configured. Let's get the actual Arduino Uno. Let's connect it up so we can see the whole process end to end, actually getting to a point of uploading the code. So we start off by unpacking it. Usually comes this anti-static wrapper. You can use this to cut it. This one actually doesn't actually need it. I can just rip that off like that. Take out your Arduino Uno. This is not a genuine one. This is just a clone because they are open source. So it's just built by someone else. You get this set of male connectors, so you can kind of solder it in, and you have male ones as well as female. If it's just easier wiring, you don't need that to start with. We basically just have that just in case. So yeah, you need a USB cable. The socket is a bit different from your normal one that you get. It's actually another format. So just to zoom in and have a look, just to make sure you get the right matching cable to meet this socket. The next step is to connect the USB cable to Arduino. Should be straightforward, right? Not always. Sometimes it takes some trial and error. You'll get in the end, but it's not usually a standard cable that you would work with. You connect the other end of it to your PC, laptop, Mac, or in this case, a USB extension hub, which sometimes makes it easier to work with. As you can see, LED, power LED comes in right away, and we know it's powered, and it's actually blinking. That actually means there's a blink sketch already preloaded on it. As you can see, it was brand new Arduino Uno, and it's already running some code that was preloaded in advance, which we'll have a look in a little bit. Getting back to Arduino IDE, we need to complete the setup from this side. So you'll go to Tools and find the right board to configure. So we go to Arduino AVIA boards and Arduino Uno. And as you can see, Arduino Uno is now selected right there at the top, and will stay like that as a selected board type. So now we go to File and create a new sketch, and we'll launch a new instance of Arduino IDE with an empty sketch. Let's pause here for a bit just to have a look at what we get with an empty sketch. You get the setup section, which is empty at the moment. It will run no code at the beginning of the program. And you have the loop section, which is any code that you want to run repeatedly, which is again is empty. So this specific sketch or this code will do nothing. So when you upload it, your microcontroller will do nothing and will just sit there quietly. One more thing. All these bits of text that are preceded by 2 forward slashes, and this text is usually in green. These are comments, so they don't affect any of the actual code. They're just there as notes that you can leave and then come back and review afterwards. So feel free to delete them or to add more and write whatever you like. Yeah, these are just for you, and they will not be translated into binary, and they will not affect any of your code. Let's upload this code by clicking the Upload button. It straight away starts to compile it, and as soon as it finishes compiling, it will try to upload it to your microcontroller, and immediately we get an error because no upload port was provided. Unfortunately, we have to go and select the port manually for the first time, but we only have to do it once in most cases. So we just navigate back to the tools and select the port section, and you can see no port is selected. It does not pre-select the port for you for some strange reason, but yeah, we'll do it manually once. So select whichever port you have available, and it will use it for all future uploads. So you click Upload again, and you can see as done compiling, it started to upload. Now, if you'll be looking at your Arduino Uno at the point of the code being uploaded, you can see that the lights, LED lights, are flashing quite fast, and then it goes into light always on, which is what empty sketch is meant to do. So back in Arduino IDE, we can see that we're done uploading. Our empty sketch is there. We've done the whole process of converting this code or lack of code into binary and then pushing it all the way to the microcontroller, where it ended up working with the empty sketch and showing LED on constantly. So there you have it. It's as simple as that. You get your code pushed all the way through to microcontroller and it's working. Now let's upload some code that actually does something. To do that, we can use a classic example used in a lot of tutorials. Simply go to Examples, Basic, and use Blink. This is used a lot because of its simplicity and relatively little code. So you can see that it started a new instance of the IDE. We just copy all the code from here and paste it back into empty sketch. This way we can edit it because otherwise it's read-only. We're just gonna do full screen and clean up some of the comments which we don't need we can read them afterwards on your own side. But yeah, just clean it up to focus on the code that we have, which is relatively few lines of code. So let's go through all this code line by line. Now, this is where the fun really begins. And the setup section at the top is where you want to put all the code that you want to run only once at the beginning, and not to be run repeatedly as the program runs. It's much easier to explain it once you have some actual code to show. So here, there's just one line, the pin mode function, where you say that this LED, which is built in, which is our LED pin, is supposed to be enabled for output. So this will allow you to write for that pin, or set it to high or to low. And yeah, technically you can put it down in the loop section, and it will still work. But it's just better practice to have everything that you only need to be run once, to have a day in setup, and then forget about it and don't worry about it for the rest of the program. And then you can focus on the loop for the actual code that you want to run repeatedly. The loop section is, as the name implies, it will run in a loop forever and ever. Again, in this case, the code is straightforward, which is why a lot of people use this example for their tutorials. You have basically one line to digital write, and you specify the pin for which you write, which is again the LED built-in pin, and you set it to high, and that will cause the LED to switch on the light. You delay for 1000 of something. That's 1000 milliseconds, which is 1 millisecond is 1,000th of a second. So that means you delay for 1 second. And then you again invoke digital write function, and then you write to the same pin, but you set it to low, and that will switch off the light. And again, you wait for another 1 second. And if you think about it, this runs, as soon as it completes, it runs again. So you can think of a copy-pasting this code infinite amount of times just below this loop, and it will just set to high, wait, set to low, wait, set to high, wait, and so on and so forth. And that's pretty much how most microcontrollers would work. They will just carry on with some kind of code in the loop. And this is the simplest example that we can think of to demonstrate. Now let's upload this code. Once again, we click the upload button. It goes through compilation phase, and then it uploads it, and we start blinking again, or rather Arduino starts doing that. That's all it takes. And as you can see, it gets easier as you get more practice. And this is as much effort as it takes to deploy some code. Something else that our IDE does for us is syntax checking. Now, for example, you can try look at your code, and then, well, in this case, we can just mess with it. We see that we're setting the LED built-in pin to high. Let's change that to a smiley face. Why not? And then we'll try to compile the whole thing. We actually can go straight away and try to upload it. And as you can see, we get an error. It actually tells us exactly the point where something is not right. It points at that smiley face and, the face with the tongue sticking out, and says that, something's not right. In this case, expected primary expression before colon, but that doesn't fully explain it. So let's try, instead of setting it to high, set it to mostly high. So what do we get? It's thinking. It actually says that mostly high was not declared in the scope. It's actually looking at that word and said, I don't recognize this word at all. So it gives us a slightly more readable error, which helps in this case. That's a start. Now, what if we try a typo? So it's almost high, but just one letter wrong. Let's see how it deals with that. But actually it says, note, suggested alternative, high. So it actually recognize that it's a typo, and we most likely meant the word high. And in this case, it's very helpful. So you can just very easily go and correct your mistake. Let's edit some of this code. You can start off by saving it. Press Ctrl S and just select where you want that to be saved. Name this file whatever you like. Just call it my test. And whenever you save, it's for some reason restarts the code window. Not fully sure why. Just the way it works. But once it's saved, you're free to change whatever you like, and the changes will be persisted on your computer. Now, what would be a good thing to change here? We can simply make the delay slightly shorter, well, actually a lot shorter. we can make sure it waits for 100 milliseconds instead of a second in between switching lights on and off. So effectively a much faster blinking rate. And we can upload the code and it will compile. It's blinking slow at the moment, and as the code uploads, it blinks much faster now. So it's actually 10 blinks per second, which is, pretty straightforward to change. What else we can do with a sketch? Well, there are obviously a lot of changes we can be playing around with. We prefer to stick to just changing timings of the blink, just to keep the things relatively simple. So we reset the delays back to 1 second as they were initially, and we just set the on time of the light to 5 seconds. So just to see the impact that will have on the behavior of Arduino. So we just upload the code, same as before. See, we're blinking quite fast at the moment, and as the code uploads, again, it flashes, and then we go to on for the LED for 5 seconds. It will stay like this in the end. It will then switch off, and it will stay on 5 times as longer as it will be switched off. So this the pin enable mode allows us to do whatever we want with this light. So feel free to play around more with this blink sketch to get yourself a bit more familiar with how this code actually works. Now, if you want to continue learning how to code with Arduino, you can carry on by following this video.